Hi everyone, so we are back at it again with another hacker rank on this is week 2 on the 1 month prep kit, and today we will be talking about page flipping, or that's what this question is called. So yeah, let's go through the question. A teacher asks the class to open their books to a page number. A student can either start turning the page from the front or from the back of the book, and they always turn one at a time, and they open the book. Page 1 is always on the right side. Okay. When they flip page 1, they see page 2s and 3. Each page except the last page will always be printed on both sides. The last page will only be printed on the front, given the book. Okay, so it's just like a normal book. So nothing out of the ordinary. They're just overcomplicating how a normal book would be printed out. So if the book is n pages long and a student wants to page 2, what's the minimum number of pages to turn? They can start at the beginning or the end of the book. Okay. So that's the game, right? So we can either start from the front or from the back. So they count this as 0, 1, and 0, 1. Yep. So using the diagram above, if the student wants to get to page 3, they open the book to page 1, flip one page, that's one flip, and they're on the correct page. If they open the book on the last page, it is page 5, and they flip one page and they get to the correct page. So the minimum value either ways is 1, and hence we return 1. So yep, seems like a pretty easy question on first glance at least. So what I'm going to do is just to visualize the edge cases if there are any. So let's say 5 seems to be a pretty small number. I'm going to set slightly bigger. So let's say page 1. There's ... 2 and 3. And another set 4, 5. And another ... 6, 7. And let's just say, okay, I'll just be fine. I'll just put 8. Okay, let's assume right now there's only 8 pages and I want to get to 3. So if I want to get to 3, I can either go from here, one flip and I get here, or I can do 1 flip, 2 flip, 3 flip. So this seems to be like if I had 9, I would also have to do 3 flips. So from this itself, we can see that if it'd be better if we can just augment these two values together and say that this is one page and this is one page and this is one page and this is one page. And to do so, all we need to do, if I'm not wrong, is okay. It's a simple operation. In Python, there's this thing, it's a double slash, which means you divide and round it down to the lowest. So I'm going to round everything by 2. So 1 / 2 would give you 0, because 1 divided by 2 is half, and half will be rounded down to 0. 2 will be rounded to 1, and 3 will be rounded to 1. It will be 1.5, which will be rounded to 1. So this will be 1, and this will be 2 to 2, 6 to 3, and 8 to 8 will be 4, and 9 will be 4.5, which will be 4 effectively. And hence, if I were to find the minimum value, right now this will be 1, while this will be 1, 2, 3. So we just need to find the minimum, which is 1, and then we can just return that value as our final answer. So the trick lies in, I don't even think there'll be any traversal, any graph traversal, anything of that sort in this question. So I think I'll just get straight to coding. So let's print out the values that I'm seeing first, just to know what I'm working with. Okay, running the code. Yeah, it's wrong. Okay, so I'm getting 6 and 2. So the first line 6 indicates the number of pages, so up until here, while the second line contains P, the page to turn to. So over here, I need to turn to page 2, which would be from the front will be 1, and from the back it will be 1, 2. So the minimum value will be 1, and hence we will return 1. Okay, so let's delete everything. And what I'm going to do now is we know for a fact the first page will be 0. We need to know what is this index going to be, like the correct pages index going to be, and we need to know what the last pages index going to be. And from there, we can just plus minus and find the value. So let's find the index of the smallest, the correct page first. So index of correct is equal to p / 2, while index of full will be n / 2. And in the end, all we need to do is we just return whichever is the smallest. So we can just do the index of correct and index of full inside. With that, I believe this should be the correct answer already. Let's see. Okay, I'm getting wrong for this. Why? Okay. So the full page is 5, and they expected us to get to 4. Whoops. Okay, I see what the issue is. We just got the indexes of the thing. I jumped ahead of myself and didn't really figure out what the answer should be. So index of the correct is the correct page, and I need to minus that from the first one. So index of, which is just something minus something, like index of correct minus 0 is just going to be itself. So I can just leave it as it is. But what if the answer is from the back? Then I need to find the index of full, minus it from the index of correct. So, and now it should work if I'm not wrong. Yep, let's submit this. Yep, as usual, Hackerrank is lagging a lot. Let's hope this works. Okay. Yep, there are no edge cases. I can say for a fact this is the fastest method to do it. A lot of times people might assume that when they see a graph, they need to do some graph traversal, but nope, you don't need to. Sometimes you might just see a quick pattern. In this question, it's quite obvious, like quite easy to identify the pattern immediately, but there are many other questions that would be really hard to find the hidden pattern that could shave a lot of time complexities from it. Because over here, they give n is 10 to the power of 5, and 10 to the power of 5 is a pretty big number if we were to do graph like array traversal kind of solution. But yeah, I hope you guys enjoyed the video, and I'll see you guys in the next video. And yep, bye.